Hey guys, this is Mr. Bennett, and this is video 7-1. We'll be talking about ionic bonding. So the first thing we need to do is we need to talk about what a bond is. Well, a bond is a force, so it's got some force or pull to it, that holds together atoms. Okay, what that does is it's going to keep the atoms together so that they function as one unit. So for example, just to use a compound that we've talked about in the past, if you have an oxygen bonded to two hydrogens, we know that's a molecule of water. So this is one unit, a molecule of water. But it actually contains three different atoms that are held close together by a force in between each hydrogen and the oxygen that we call a bond. Now there are really three types of bonds out there. You have at least three major types of bonds. There's actually more than three, but the big three are the ionic bonds, covalent bonds, and metallic bonds. In this particular unit, we're going to focus on ionic. So we're going to spend most of our time talking about ionic bonds, and then at the end we'll get a little bit into metallic. We're not going to talk about covalence until unit 8. Okay? So don't worry about covalence right now, focus on number 1, and then towards the end of the unit, keep an eye out for number 3, the metallics. Now, what we'll find as we finish up unit 8 is that after talking about all three types of bonds, the type of bond that you use in a particular compound really depends on the type of atoms that are held together. So just with ionics, for instance, today, you'll find out that specific types of atoms have to come together in order to form an ionic bond. So it's all about the type of the atom. Now, ionic bonds specifically, let's talk a little bit about what those are. First of all, an ionic bond forms when you have a cation and an anion. Okay, they have to be held together, or basically a force we call a bond has to group them up. Now, cations, this is a general term. It means anything with a positive charge. So it could be a metal. We know that all metals form cations, or it could be a positive polyatomic. So something like hydronium, which is a positive polyatomic that we learned, as well as ammonium, NH4 plus 1. So either one of these are both polyatomic cations. Metals would be something like calcium as an ion or lithium as an ion. Okay. Your anion, on the other hand, could be a nonmetal, so it could be something like fluorine or fluoride because it's an ion, or it could be something like, for instance, oxide, an oxygen ion. Or it could be a polyatomic. We've talked about a few different polyatomics that are negatives. It could be something like phosphate, PO4 minus 3, or something like hydroxide, OH minus 1. Any of these could act as your anion, and any of these could act as your cation. Point is, they're held together. So the classic example of an ionic bond would be between sodium and chlorine. They come together to make sodium chloride, or table salt. The thing that's actually holding them together is the fact that sodium has a positive charge, and chloride, or chlorine, the chlorine ion, has a negative charge. This is what we call electrostatic forces, when a positive charge is attracted to a negative charge. And we see this all around us all the time. So static electricity, static cling, a balloon making your hair stand on end, really the way that magnets work, attaching, positive charges are attracted to negative charges. Okay. Now this strength, this electrostatic force, is actually kind of medium in terms of bond strength. So there are some bonds that are stronger, and there are some bonds that are weaker. We'll see that by the time, again, when we're done with Unit 8, we'll see that ionic bonds kind of fit in the middle. They're about medium strength. Other characteristic about ionic bonds is that the substances that we make through ionic bonding typically have high melting or boiling points. So they're typically going to be solids at room temp, because in order to get them to melt and become a liquid, they have to get very, very hot. Okay. As far as their physical state, so we said they're solid at room temp, but specifically when you look at them, they look like crystals. So salt, again, is a good example. Salt comes as salt crystals, right? At room temp, it's a solid, and it's got that crystalline shape. Ionic bonds also, when you dissolve them in water, have the ability to conduct electricity. And what that means is that ionic bonds are what we call electrolytes. We talked about these guys last unit. Electrolytes are substances that when you dissolve them in water, they form ions, and they have the ability to conduct electricity. Last but not least, if you have substances and you combine them using ionic bonds, we call them ionic compounds. Okay, so let's talk briefly about what happens. Okay, how does this ionic bond form? Well, it's the result of an exchange. The idea is that the electron will leave the metal and it will move to the non-metal. So the electron is being given away from one atom, it's showing up or being taken by another atom. The reason why this will work is because, first of all, metals have low ionization energy. That means really they're loosely holding their electrons, right? It's very easy to pop off an electron from a metal because they don't have a lot of ionization energy, so they're loosely holding their electron. Non-metals, on the other hand, have high electronegativity. This means they have a high attraction for electrons. So non-metals are great at picking up new electrons. Metals could care less about their outer electrons, or valence electrons. They're only loosely being held. So it's kind of natural that these guys would attract the loosely held electrons that metals have. When you do that, the metal is going to become a cation, and the non-metal gaining an electron will become an anion. Once you have these two opposite charges, it's just a matter of time. They're near each other. Electrostatic force, or opposite charges being attracted, will pull them together. So here's an example. We have sodium chloride, again, table salt. If we look at sodium, sodium has one electron to give away. Notice here in the picture, sodium has one electron in its third energy level, in its valence energy level. If it gets rid of this electron, then its highest, or valence electron energy level, will be the second level. And notice that second level has 1, 2, 3, 4, 5, 6, 7, 8 electrons, an octet. So if it can just get rid of this electron, it will have that octet in the second level, and it will be more stable. Chlorine, on the other hand, has its valence electrons in the third energy level as well, but it has 7 valence electrons, right? 1, 2, 3, 4, 5, 6, 7. So if it can just gain one more electron, it will have 8 electrons in its third energy level, again reaching an octet, becoming more stable. So this electron is going to be given away by sodium, and it's going to be picked up by chlorine. When that happens, sodium now has its octet in the second energy level, chlorine now has its octet in the third energy level. They're both happy, they're both more stable, but sodium now has a charge of +1, chlorine now has a charge of -1, and electrostatic force, or opposite charges being attracted, will stick them together, hence forming an ionic bond. So once you have something like that, where a cation and an anion are stuck together, that is what we call an ionic compound. Just a cation could be a metal, something like sodium we just talked about, or it could be a polyatomic like ammonium, will be stuck to or bonded to an anion, which could be a non-metal like chlorine that we just looked at, or a polyatomic like hydroxide. So another example of an ionic compound would be something like ammonium, which is NH4+, being attracted to hydroxide, which is OH-. They both have opposite charges. These are two polyatomics, right? But they have opposite charges. This is +1, this is -1, so they're going to get stuck together, and if they did, in fact, you would get a compound like this. So they're now stuck together, they have a neutral charge, the positive and the negative cancel each other out because they're stuck together by electrostatic forces. So this is what we call ammonium hydroxide. Okay. When these ionic compounds form, they'll form crystal shapes. We've already talked about that. And the big three examples of ionic compounds are acids, bases, and salts. All right, that's the end of our video for today. So make sure that you complete your WISC questions and create your hot question, and we'll see you tomorrow.